everyone. Thank you so much for attending today's training webinar, which is titled EPA's Decision Support Tools for Disaster Waste Management, Municipal Solid Waste Decision Support Tools. So this is the second training webinar of the EPA training webinar series. So as you may know, EPA has developed a lot of the tools, decision-making tools that is useful to guide you on the waste-related decision-making. So before we move forward, I would like to let you know that this training webinar is recorded and will be available on the SUMMEER's YouTube channels later after this training webinar. So before we get started, I also would like to give you another reminder, especially for those who are not part of the SUMMEER. So if you are not the SUMMEER members, I would like to encourage you to join us using by scan this QR code. Once you scan this QR code, you are directed to our SUMMEER webpage where you can actually join the SUMMEER. So SUMMEER, as like other NSF-sponsored organization, we are the reconnaissance organization with a focus on the sustainable disaster waste management. So we have the definitely other interesting training opportunities toward the end of this year. So for those who are interested in sustainable waste research, please join us using this website. So now I would like to introduce today's speakers, Suzanne Thornors and Keith Waite. I know, Suzanne, I didn't pronounce your last name correctly, but I did my best. So Suzanne is a senior chemical engineer with the US EPA. Suzanne has also led many research projects, including the understanding partitioning of the pollutants in the environment from the coal ash and other waste material we consider for the beneficial use, land application, and treatment and remediation. So Suzanne actually also pioneered the use of the life cycle assessment methodology for comparing alternatives for waste management to maximize the resource and energy recovery from the solid waste management. Suzanne also led the development of the Municipal Solid Waste Decision Support Tool, which is a topic for today's training webinar. We also have the other speaker, who is the Keith Waite. He has the 30 years of the experience at RTI International, where he leads the research in life cycle assessment and solid waste management, solid waste and materials management. He also specialized in the development of the life cycle assessment data, method, and decision support tools to support the public and private sectors decision makers. So Mr. Waite is currently leading the work to support the EPA's sustainable materials management and circular economy initiatives. Please join me welcoming today's speakers. Suzanne or Keith, you may want to share your screen.
Well, this is Susan. I don't plan to share my screen, but I wanted to just say a few words before I turn it over to Keith for the demonstration of the tool. This tool has been in existence for about 3 decades. We've done a major improvement of it through funding from the National Science Foundation. This is now version 2, and Keith will be going through many of the improvements that have been made. We've included digestion for looking at how food waste can be managed either through composting or digestion. We've also included an accounting mode. And so this tool has been widely used by a number of communities around the country. In fact, we're currently conducting studies at 10 different communities to contrast and compare how their waste infrastructure works for solid waste management for both residential and commercial sectors. And we're also using the tool to help with the with climate change, we're seeing a lot more natural disasters. In Florida, you've been seeing your share for certain for quite a while, and even more now. And so having to deal with that waste along with your solid waste is quite challenging. So anyway, this tool allows you a way to better understand the life cycle environmental trade-offs, the cost, as well as we've included environmental justice, so you can look at those aspects for your specific community. And Keith Weitz is from Research Triangle Institute, and he's going to be the person to provide the demonstration. Thank you so much.
Okay, it's a pleasure to be here today and to walk through the model with everybody. Please feel free to ask questions as we go along here. I've been working on this project and the model for decades now, so it's all second nature to me, and probably very new for you. So if there are specific questions or clarification that is needed along the way, or feel free to interject either in the chat or the just on screen is fine as well, and I can answer that. As Susan mentioned, we have been working on this particular tool for quite a long time, and Susan started this work back in the early 1990s, and we worked with a group of organizations over the years. So this is not just an RTI led effort. We have worked with many different universities, including University of Wisconsin in Madison. North Carolina State University has been a key partner in the development of the tool, and they continue to work in this area on their own version, which is called SWOLF. We've recently worked with Eastern Research Group on various aspects. One has been data for different life cycle elements and materials through their company that they acquired, Franklin Associates. And they also have helped recently with redesigning of the user interface and design of the new interface, which I will get through. And there's also been a long list of peer reviewers that have been involved and stakeholders that have been involved over the years. We had many peer review and stakeholder meetings, particularly in the development of the first version of the tool, which was in the 1990s, early 2000s, because we were really sort of breaking new ground here in terms of developing life cycle process models for different waste management activities. And the data, the methods for calculating the process flows, the life cycle inventory data had not really been established. So it was a good opportunity for us to work with many different stakeholders and get them engaged, get their buy-in on what we were doing from a data methodological perspective, and we were able to implement it as part of the tool. The first version of the tool, I'm showing you the RTI site where the tool is housed. We've been acting as custodians of the tool for years. The work was originally co-funded by US EPA and US Department of Energy, and US EPA has been the sole funder for many years now. But the first version was pushed out as a publicly available downloadable package in around 2010, perhaps. And we have upgraded it over those years. So every year we go through an annual upgrade cycle. You can actually go to the site and download the previous or the first version of the tool, and there's some online tutorials for how to use the tool. We've been working with Susan and EPA for the past few years to develop a new version of the tool, version 2. That is, we have posted a test version for testing purposes only. but it is still undergoing testing, refinement. We recently recognized or identified a few different bugs and errors that have fixed, and I have a new package that we will post up. So I would not download the current version of the version 2. I would wait until we have a new version to post, which should be very soon here. So what I'm going to walk through today is the version 2, because that'll be the most recent version that we push out. And to give you an idea of what's happening in the model, the tool is both an accounting tool and an optimization tool. In the first version we had, the tool was always running in an optimization mode. So if we had selected an optimization objective, such as finding the least cost way to manage the municipal waste, the model was always trying to find the least cost way. We were able to simulate different scenarios through setting of mass flow constraints and other constraints, but it was always running in optimization. In the new version, we made a split between accounting mode and optimization mode. So you can actually run the model now in a pure accounting mode, which you can dictate, I want X tons to go here, Y tons to go there, versus an accounting mode, versus an optimization mode where you're solving for an objective, whether that's least cost, minimum greenhouse gas emissions, or another objective. And the model will find the solution that best fits that objective. I'm going to walk you through the accounting mode. Optimization mode has the same basic steps, but it has an additional step where you select what you want to optimize on. So I guess first of all, as you saw on the website, there is a installation package that's available. So the tool actually resides on your computer. You download the installation packages and it installs. There's an automatic installation routine, so it will automatically run through the installation and install on your computer. So the tool itself resides on your local computer. It's not designed for Apple, it's designed for PC. So I know people have tried it on Apple and sometimes it works fine and other times it doesn't, but we cannot guarantee that it will work on an Apple computer. But we do know that it will work on a PC for sure. So I'm going to just set up and walk through how we run the model. And in terms of scenario name, what's happening here is we're just initiating a model build. So what it's doing, it's creating a distinct and individual model for whatever we name it as. So typically we're working with communities or regions. So this could be Orlando, Florida, for example. And I would be basically setting up a tailored version for Orlando, Florida. The value for that is that you can always go back to your model build for your community or communities and update it. So once we set up a model once with community level information, then it's all there and we can always go back and either update the data that's as it gets updated by the community, or we can change different parameters, run different cases. So I'm just going to create a test case here for today, and Zoom may kick me out. Susan, if you can let me know if it kicks me out or doesn't advance the screens.
Will do.
Yeah. I know Teams does that regularly, but I forget Zoom if that happens as well. And somebody had a comment about whether we will be creating a version for?
I answered.
Okay.
I said no. I'd prefer an Apple, but we don't have the funding.
Yep. Okay, so can you see the waste generation screen, Susan?
Yes.
Okay, great. So it hasn't kicked me out.
Okay, no. It says accounting mode, new scenario, test July 13th, starting point collection.
Okay, so it did kick me out actually. Okay.
It did kick you out. I'm so sorry.
No, you're fine. Let me just stop and reshare. Usually for whatever reason, it does it once and then it doesn't do it again. Okay, can you see the waste generation screen?
Yes,
Okay,
yes.
great. So the first step, let me get this bar out of here. So we designed the interface so it walks the user through a series of steps to enter data. The model itself is populated with default national US data for many things, but what we like to do is tailor it to a specific location using location, whether that's a community, a county, a region, a state, using their specific data for how much waste is generated, its composition, and existing management infrastructure. I'm just going to put in some dummy variables for now. So just some hypothetical numbers of 100,000 tons per year and 10,000 households. You'll see here we have the ability to model different sectors. So we have a residential household single family sector, we have a residential multifamily sector, and then we have a commercial sector. And the commercial sector so single family sector is single family households, they're individual households. Multifamily is an apartment building. Commercial can be a wide variety of things. It can be restaurants, it could be institutions, offices, etc. Ultimately, we'll build out multiple sectors for each of these, so you can have more than one sector. But for this test version, we have one sector of each. The most communities collect and report data by sector. So that's part of the reason why we have this sectoral definition. The other reason is that different generating sectors can have different generation rates, they can have different compositions. So you can think about, for example, an office building versus a restaurant. They will have very different types of waste they're generating. So the ability to define waste by sector allows us to get at an additional level of detail about what's in the overall composition of waste that's generated. I'm just going to use the one slot for residential. So let's just model single family homes that are generating 100,000 tons per year in our hypothetical community. Susan, that advanced over to composition?
It did.
All right, yep. For whatever reason, it happens once and then never again. So this is where the next step is to enter a composition for the residential single family tonnage. So if we had different sectors, they would show up here and we could select each sector and enter a specific waste composition for them. This waste composition that's in here is the default US national average. And compositional data is one thing that varies from location, community to community. So we do like to get local compositional data. The other way we can use this model is to look at specific waste streams. So if we were interested in food waste, for example, we could zero everything out and put in a mix of vegetable, non-vegetable food waste and look at specifically options for collecting and managing only food waste. or if we were interested in plastics or other material categories, you could use the tool in that manner as well. If you use it in that manner, you have to realize the context of how waste is typically managed, and it typically is not collected as an individual stream of material. I think yard waste and sometimes food waste are somewhat unique in that they are often collected separately from other materials. But most everything else is typically mixed with other materials as part of collection. So you can see here there's a list of specific waste items, and there's a number of open slots. So you can actually use these open slots if you have other waste items that you would like to model. I'm not going to change anything here. I'm just going to use the national averages. The next step is to define how that waste is collected. So typically you have residual waste collection, which is your trash can or bin. And then most communities now have a single stream recycling, which means you have one bin, typically your large blue bin, that you put a mixture of recyclable materials in. And sometimes you have yard waste collection. There's also other types of collection, such as drop-off locations where you can take trash, recyclables, or organics and to a centralized drop-off facility. You can have a leaf vacuum. I know in our community, the leaf vacuum truck is driving around almost every week. For now, I'm just going to have recyclables collection, and the remaining trash is collected as a residual. And so based on the selection of how waste is collected, the next screen will give you options for how that material can be managed. So for example, since I didn't select any yard waste collection, there's no composting or digestion included as part of my options because I don't have material that can go to composting. I would need to select yard waste or organics collection. So what I will select is a landfill, and I will select a single stream MRF or sorting facility that matches my single stream collection. I also need to select this, what's called reprocessing, which basically tells me that the material from the MRF goes into a recycling chain and gets recycled into new material. You'll notice here on the right that there's sort of automatic validation built in. So if you need to add something or have something incorrect, it'll show as a red. If you have everything correct, it'll change to valid. You have a mix of options that is valid, and you can move forward.
Okay. Case is the overview of your the end of your presentation?
No, I'm just waiting for it to get to the next step.
Okay.
So I clicked on the next button, and it sometimes takes a few minutes when we're showing it on the screen for, I don't know why. But, so when I mentioned at the start that we're running in accounting mode, what accounting mode enables me to do is define a split of where I want the waste to go or the material to go. So in my case, I only had selected that residual waste collection and one landfill. So if I wanted to, I could also add a waste energy option. And what that would do is give me another type of facility that I could send material to. sorry, I need to now wait for it to get to the next step. It typically moves through the steps pretty quick, but for whatever reason, when we're showing on Zoom or Teams, it gets held up a little.
And by the way, when we talked about doing 10 community case studies, Orlando is one of the 10 communities.
So you can see now that we've added a waste energy option as a possible option for dealing with our residual waste. We have open cells that we could define a split. So I could say, you know, I want all my residual waste to go to a waste energy plant, or I could say that I want it all to go to a landfill, or I could do something else that says 50-50 split of my residual waste between a landfill and waste energy. For now, I'm just going to do a base case where let's just send it all to a landfill. The only place I could send my single stream recycling is to the MRF, so that is all going to go to my MRF. So the next part of the tool really lets me tailor the default settings. So there's a few different settings that are available for users to change through the interface. High level and more detailed local level. So one thing that is important is the regional electricity grid, because the tool is calculating a life cycle energy footprint. Any electrical usage by a facility, such as a recycling facility, calculates not only how much electricity is required per the tonnage of material flowing through that facility, but also the resources and emissions associated with producing that electricity. And that's part of what makes it a life cycle approach. And so if I'm in a region that has a large renewable grid mix, such as we have a lot of hydropower on our grid, versus a region that has a large fossil component like coal on their grid, the emissions per kilowatt hour of electricity produced can vary quite widely. So this lets us select a regional grid. We can also specify a custom grid. Sometimes, as you can see, these regional grids are pretty large. So taking Washington State, for example, they have a lot more hydropower on their local and state grid than this Western region as a whole. So this just allows us to select which grid or specify a custom grid. Global warming potential is another thing that we have put on the main interface. And this is really two things. So one is what global warming potential factors do we want to use? There are the IPCC AR4 and AR5 factors you can select from. You can also select different aspects to how carbon, in particular how biogenic carbon is accounted. So we can specify a 20 or 100-year time horizon, and based on the 20 or 100-year, the global warming potential values will be different because they are different based on those horizons. In terms of biogenic accounting, what this primarily refers to is what to do with CO2 emissions that are from the degradation of biomass or biogenic sources. So in a landfill, for example, you have methane that's generated, and that is not considered biogenic. But if you burn that methane in a flare or energy recovery system, then it converts it back to CO2, and that CO2 is coming from organic/biogenic sources, so that's considered generally as a carbon neutral emission at that point. There's also whether we, so there's a setting for whether we consider those biogenic emissions as a positive. So for CO2, for example, is the global warming potential 1 or is it 0? So if it's neutral, it's 0. If it's positive, if we want it to be counted positively, then it would be a 1. The other aspect of this that we capture is carbon storage. So when you put organic material in a landfill, for example, it doesn't completely degrade. So there is a portion of the carbon that gets stored or sequestered in the landfill, and that is calculated. And there's different ways and different perspectives about how to include that in the results. For example, should that be netted out of the landfill results or not? So this is where we can select an accounting scheme that either is storage neutral or storage negative, meaning it nets the carbon storage out of the result. There is also carbon storage associated with other activities, primarily composting and anaerobic digestion, where you are land applying a finished compost product or composting of the anaerobic digestion digestate. So there are some carbon storage / sequestration benefits for those as well. So this is not just for landfills, it's for landfills, composting, and digestion. I'm just going to keep the default settings here and get through our build. We can also specify collection modes and distances in terms of how waste is collected from different sectors, the distance between the collection route and our facilities. So this is for residual waste collection. We can also do one for our recyclables collection and any other any other collection streams that we have in here. So this just gives us a way to
So Case, we actually have I can see some questions asked on the chat. So the question is, I'm not clear why the classifications making landfill gases neutral or positive.
Yeah, it's the landfill gas is positive. What that refers to is the potential biogenic carbon emissions or biogenic carbon that is stored in the landfill. And Susan, I don't know if you want to interject on this.
There's some really good papers out there, and it's accounting for what comes from carbon from fossil versus carbon from biogenic. And so some people don't account for that. We do, and we allow the policymaker to look at it in whatever way they want to. I mean, to me, carbon is carbon, whether it's biogenic or fossil, but some people don't count biogenic, whereas others do. It's only the fossil. And so anyway, we could stay on this topic for a while, but I want to make sure we get to questions. And so let's keep, and what I'll do is I'll pop in a really good manuscript that does a good job talking about this.
So landfill gas is calculated and quantified. Really what the subject is regarding is how to treat the biogenic fraction or emissions. And I know one of EPA's tool, the WARM model, for example, automatically nets out the landfill carbon storage from the landfill result. All we're doing is providing users with the ability to include or exclude that landfill carbon storage sequestration storage amount or estimate, so that you can see, how the results play out with and without the biogenic storage being included. So in addition to the collection distances to facilities, we also have some other transportation distances. So this refers to things like residuals from the recycling facility and where do they go, or residuals from combustion and where do they go and how far that facility. So all these are just transportation related distances that you can tailor to a specific community. Process model data, for each of the process models in the tool, there is a individual worksheet or set of worksheets that sort of house the default data and the methods and intermediate calculations. What we've done on the interface side is pull or provide access or a link to what we feel are sort of key parameters that users have data to change and would want to change. So these are not everything. And you can actually go into the Excel workbooks and worksheets and change things there. This just provides a more easy portal to access those common parameters that people would change. So for example, our collection, we can go in and again, this is just sort of pointing to different points in the collection workbook, which is the single family collection. And we can change things like how often is waste collected. Typically your trash is collected once a week, but other things like recyclables or organics maybe once every other week, or something else. We can also select things like capture rates for recyclables. And what a capture rate refers to is, in this case, let's take newsprint. So for newsprint, each household or households or generators will generate a certain amount of newsprint. And there's a fraction of that actually gets into the recycling bin, or that the household puts into the recycling bin versus the trash bin. And so we can go and tailor these values. So I can go through and say like, we're gonna assume 90% of all the paper makes it into the recycling bin. Or whatever, 75%.
And this is where we get specific with the community. Some communities are just more, they're just better at collecting and having less contamination, and others not so much. So it's just allowing us to account for that.
Correct. So this just as an additional level of refinement. It also lets us look at sort of the impact of improving things like capture rates through education and outreach or other programs. So if the community is only capturing 50% of the potential recyclable materials, meaning only half of it's getting into the proper bin, and they want to look at, well, what would be the revenue and environmental benefit if we increase that to 75%, then we can look at those kind of changes. Another key variable here for recycling is what we call a participation rate. So it's set at 83%. And what that means is 83% of our community or region has curbside single stream recycling. If my entire community has it, I could change that to 1. And that means everybody has access to recycling via a curbside container. So those two factors, the participation rate and the capture rate, really dictate how much of the recyclable material generated makes it into the recycling stream and gets sent to the recycling facility. So there's values like that we can change. We can also, sticking with recycling, we can also specify different sort of design and operational parameters. Some key things here are the separation efficiency by material. So what this is saying is that 93% of the incoming newsprint gets sorted and into a bale of newsprint. So you have about 7% is residual that needs to go to a landfill or another management option. So this, again, we often work with local facilities to learn about sort of their separation efficiencies by material, their residual rates. You know, we've done research on residual rates for MRFs, and they range anywhere from 4 to 20%. So there's quite a different difference from location to location. Another thing that is important for recyclables is the price that is that the material sells for, and these prices go up and down. If you follow sort of recycling news, you see that, you know, markets change daily, and these prices sometimes are up, sometimes are down. So this is another important factor, because given the amount and type of material that is recovered and sold, will greatly impact the revenue that's achieved from recycling. And, you know, these rates will govern that revenue, of course. For other material, other options like landfills, important parameters are how gas is managed and the efficiency of gas management. So we can either have energy recovery or not. We can specify the efficiency of the gas collection system under different time periods. So all this just gives us a way to simulate existing facilities or predefined facilities as we need to. And we can always go back and change those assumptions or settings and look at a range. So if we don't know what our efficiencies are for different things, we could iterate that efficiency by 5 or 10% and develop a curve. So all this data basically gets uploaded to the appropriate Excel worksheets, and the model then gets ready to run for us. Yeah, I see another chat. Okay, that was a response.
So far, I'm keeping up with it. And
Okay,
we're going to
thank
have
you.
time for questions. I want to make sure everybody's got time for.
Yeah, I'm just going to run through this case, and then we'll sort of open it up, and we can either walk through specific components of the model, or you know, field questions, or do some specific runs. In the previous version, we actually had a much longer tree for inputs, but we found that that often was too confusing for users, and we really didn't use much of it, either because there isn't good data or it's not data that communities typically have at hand. So we greatly simplified it. Plus, as I mentioned, you can easily access the Excel workbooks directly if there's more customization that's required. I'm just waiting for it to get to the next step here. Here we go. So we're now at the step where we can basically create a report, a calculator report for the scenario that we set up. You'll notice there's two sets of things here. The one on top is for accounting mode. If I were running in optimization mode, it has a separate pathway, and you'll notice that there's a GLPK path here. That's the solver we use, is the GLPK package. And so those two run in sort of different modes. So I am going to hold on, I need to minimize a few things here so it doesn't push. Okay, so I hit create. it's asking me to save the workbook. So there's a prompt that shows up. It doesn't show up on your screen, and I'm not going to switch over to it, but it just asks me to basically name the workbook that I'm saving. So I'm just keeping it as test July 13, and it's creating my results workbook. And it's going to take a few seconds here for it to finish creating that workbook. And because I'm running in accounting mode, and I specified a pretty straightforward case where, all of the material that's collected as a single stream recyclable goes to a MRF for recycling, and all the residuals go to a landfill. It's a pretty straightforward case. But oftentimes we're working with communities that have waste going to many different places. So sometimes it gets a little more detailed, and the results actually split the totals, or they calculate results for each process. So one of the nice values of the model is I can see what my cost and energy and life cycle environmental footprint is for collection versus recycling versus landfill disposal. I can also see that by material. So once it generates, I'll show you the workbook that's created. For this new version of the model, we have one workbook that's created that has multiple sheets in it. The previous version of the tool, you selected which sheet you want to develop. So there's a mass flow sheet, there's a cost sheet, there's a life cycle impact sheet. That's all contained in the one file. Previously, they were generated as separate sheets, but we typically were using them all, so we just put them all in one file. And the sheets are tabular, they're Excel, so you can grab them and create whatever result charts, bar charts, pie charts, etc. you want to create. With Susan and EPA, we helped them build a back-end visualization tool. So you'll notice when I was on the website that there was a download for a visualization tool as well as the version 2 of the model. That visualization tool takes the outputs, and you can upload them into the visualization tool and create mass flow diagrams, Sankey diagrams, as well as different charts, bar charts, heat maps, etc., for different things. So that's actually a pretty nice feature. And as I mentioned, the prototype of that is up on the website, and it's specifically designed to handle a sheet. So you just select what result sheet or workbook that you want, and it will automatically upload that. Like I said, it runs slow when I'm on a webinar, so it's still cranking away here. Normally, it just takes a few seconds. Are there any questions while we're waiting?
We've got a question. How can we best tailor, customize this model to address post-disaster waste materials instead of MSW? For example, I think changing waste generation and composition is one clear way to get started. Yeah. What other parameters in the model are there to consider?
Yeah, I think well, for one thing, the tool is not designed as a disaster debris management tool, so you are going to be somewhat limited. So what we can do is tailor the generation and compositional values as needed. The other changes that could be made would be largely in the facility specific settings. So if there is a certain type of facility or site that the disaster debris is going to, and we know sort of the design and operational parameters around that site, then we can tailor those as well. Some things we can't do in the model are things like having a temporary storage location. So we can model a transfer station, but it's more of a formal transfer station. It's not a informal staging area where stuff may be stored, disaster debris may be stored before it can go to a facility.
We have other tools that do that, and it still gives you a way. And these 10 community case studies I spoke about, we're also looking at how they manage disaster debris, because I mean, generally disaster debris, you're managing it on top of your MSW, and like in Florida, you guys do that really well. I think you're ready to view, Keith. But in other communities around the country, they're not. And so, you know, finding more regional solutions is a really good thing. I don't see it buzzing anymore, Keith. Maybe we can view it.
I stopped my share for a moment to see if that was getting it hung up.
But you're welcome to call us back, and then when we get the 10 community case studies, we're going to have a storybook that shows kind of what different communities around the country are doing. In Florida, you guys are ahead of the game. You generally have contracts in place before an event even occurs, and not everybody's that way. And disaster planning is just really important, and you guys do a good job in that. But I mean, obviously, having the hurricanes you've had is really caused you, but you've been leading the way on how best to do it. So.
Yeah, and for the most part, the facilities are pretty similar. Like a combustion facility that is taking disaster debris is probably the same facility that would take municipal material as well.
Absolutely.
Same with a landfill. You do have some dedicated C&D type landfills. And, you know, the probably biggest difference in terms of modeling would be whether, you know, those sites may or may not have a gas collection system, for example, or they may manage it differently than the municipal waste landfill.
We've got less than 10 minutes, Keith.
I think we're up for 1:30, right?
No, I think 1.
Is it 1 or 1:30?
Yeah, it's up to 1.
Okay.
Yes, we only have the 10 minutes left. 27 minutes.
Yeah, so let me just go ahead and
I just want to make sure everybody's got a chance to ask questions if they have them.
yeah, let me just go ahead and pull up.
Sorry, I thought I'd said 1 o'clock.
I'm just going to pull up a result file so we can see that.
Yep.
They're like, no, please stop. Yeah, regional solutions, if you can go regional, that is just the best way you can do it. It's just more communities need to, you know, like in Wake County, I live in Raleigh, and they have 50 different contracts, entities managing solid waste. I mean, it's so inefficient. And so when you go to regional, it's just way more better for the environment, better for the economics.
Yeah. So this is the workbook that is output from the model. So when you do a run, it'll generate a workbook. You save that with a unique name, and then you can press the view button on the interface, and it'll pull up the workbook. These workbooks are also saved on your local machine, so you can, you know, do a number of runs, generate a number of result workbooks, and compare contrast results, or then use those to create your own summary for different scenarios that you run. So in terms of what's in these workbooks, as I mentioned, there's a mass flow. So this just tells us how much material by type. So this means we have 4,670 tons of leaves that are generated and collected, and it shows sort of where they're all going. So it's that fraction is going to a waste energy plant, and then the residual, which is ash, it goes to the landfill. If I have recyclables, that's going to show up in the sort of separation. So this run looks like really what it was just some waste energy and landfill disposal. So you can see by process or activity how much material is going where.
And although we have this tabular with the visualization tool Keith was telling you about, you can also see a visual depiction of what this looks like across the waste infrastructure. So, but yeah, these numbers are really the guts, and then but we have easier ways, because when you're communicating with the public or whoever, the easier, and we even have heat diagrams so that you can see where they want to see the visual version. Keith, you've got all of 4 minutes. I'm so sorry, guys.
No, we're good. So I'm going to just show real quick what Susan's talking about here. So we're able to generate these numbers all feed into a visualization, and we're able to generate through that a Sankey diagram. And you can either generate the Sankey diagram through the visualization tool or download it to your machine, and then you can play with it from there. You can move these bars around, etc. But as you notice, the results sheet I was showing has this mass flow Sankey. So this is just a transposition of the mass flows into a format that the Sankey diagram can read.
But we also have like the LCA environmental trade-offs. We've got that in a heat map, and I don't know if you have time to show that, Keith.
Yeah, it depends if everybody can stick around for a couple more minutes. I could pull those up quickly as well, but this sheet shows the cost. So this is the total system cost for the scenario, and this is the cost breakdown by individual operation. So it tells me my collection costs, my cost for the waste energy and landfill disposal. This is just over here, it's the same, it's just a further delineation. So this is like the total collection cost, but we may have 3, 4, or 5 different collection activities going on that will also have a split. Same with the life cycle inventory outputs, and this is a long laundry list of inventory flows. We have taken those and put together sort of this master sheet or standard sheet with a shorter list. So these things up here above are things like global warming potential, renewable energy. They all flow out of EPA's Tracy model, which is a life cycle impact assessment model. So they get at environmental or ecosystem level impacts or human health impacts. And down below here is a set of emissions that is pulling from this long laundry list and compiling like all types of CO2 fossil into this one category. So you can see here that it reports everything again as a net total, but then also by process. Let me stop this and show you some of the diagrams that are generated. So it finally created my model, my result file for the.
So Keith, unfortunately, we have only 1 minute left. So
you've got a hard stop. So thank you so much. And maybe you'll have us come back when we finish the Orlando work, and we can show you how that compares to other communities and the visualization. And that also includes disaster debris management.
Yeah, so I will show real quickly this is an output. In the visualization tool itself, it shows up a lot nicer, but if I export it to Excel, this is how the output looks. And it just shows me what's a positive or negative. So blue is better, orange is worse in this case. And so I can get a quick read on, by scenario, what is more positive, what is more negative. So,
Right.
you know,
Thank you.
feel free to reach out to me, and we certainly like people testing the tool, using the tool for us in your own research, because that helps us refine it, make it better. So I do welcome you to grab the tool and play with it.
Okay.
All right. Thank you so much.